Peace and blessings of Allah be upon you, our highly respected viewers. You are welcome to the Education Committee tutorials organized by Muslim Student Society of Nigeria, Kano University of Science and Technology, WUDIL branch. The next one is, let's just rush and see how to solve using completing the square method. Now there is something you should note. Not all quadratic equations can be solved using factorization method. There are some quadratic equations that cannot be solved using factorization method. So for a quadratic equation that cannot be solved using factorization method, you either use completing the square method or using quadratic formula. Now let's see completing the square method. Square. I think we solve one example, 2x squared plus 7x plus 6 is equal to 0. Let's just use this one and solve it using quadratic equation method. So simply completing the square method. This completing the square method is very simple, but there are steps you should follow. Now the steps is that the first step is you should divide through by the coefficient of x squared, which the coefficient of x squared here is 2. So you have to divide through by 2. Divide through everything. Equal to 0 over 2. So this 2, you cancel this one. X squared plus 7 over 2x plus 3 is equals to 0. Having divided both sides by 2, this 3, just take it to cross the equality sign, so that we are going to have x plus 7 over 2, x is equal to minus 3. So now, having done this, the next thing is constant. Multiply the coefficient of x by 1 over 2 is constant. 7 over 2, just multiply it by 1 over 2. If you multiply this by 1 over 2, you're going to have 7 over 4. So, if you have the result here, the next step is you square the result you have. This result, square it, then add it to both sides. Add it here and add it here. So we're going to have square. So add it here, let's see. X squared plus 7 over 2, x plus 7 over 4 square is equals to minus 3 plus 7 over 4 square. There's next step. The next step is just factorize the left hand side. You are going to factorize the left hand side. Now, without wasting time or taking more of your time, to factorize this is very simple. So to factorize it, you just take x plus whatever is this. That is the first multiply. When you multiply by 1 over 2, whatever is inside. Plus, it goes with whether plus or minus. If it is minus here, you put minus. But it is plus, you have to put what? Plus, then what is here? 7 over 4, then square it. If you do this, it means that you factorize this one. Then it is equal to minus 3 plus 7 square here is 49, divided by 4 square is 16. So the next thing is, we are going to solve the right hand side to make it a single fraction. After we make it a single fraction, then we square both sides. Let's see it. We have x plus 7 over 4 square is equals to LCM here is 16, sorry. 16, let me put 1 here. 16 and 16 in 1 is 16. 16 times minus 3, we are going to have minus 16 times 3, this is 8, this is 48. 16 in here, we are going to have 49. So we have x plus 7 over 4 square is equals to this and this. We are going to have 1 over 16. Now we are having a single fraction. Having a single fraction here, you just take the square of both sides. That is, square this root of both sides, sorry, not square. Root of this square will go. We are going to have x plus 7 over 4 which is equals to root of 1 over 16. Don't forget, whenever I put a root, you have to put together with plus or minus. So at last we're going to have 7 over 4, which is equal to plus or minus root of 1 is 1 over root of 16 is 4. So I mean, this just collect like terms. This one should move to the other side. We're going to have x is equal to plus or minus 1 over 4 minus 7 over 4. Just the LCM. The LCM is 4. X is equals to 4. We have plus or minus 1 minus 7. So when you reach this stage, you take, let me complete it here. You take x is either equal to the positive 1 minus 7 over 4, or x is equal to the negative 1 minus 7 over 4. That is when you come here, you have to split. You take the positive 1 and you take the negative 1. Let's solve the first one. X is equal to 1 minus this. We're going to have minus 6 over 4. Or x is equal to 1 minus this. We're going to have minus 8 over 4. So at last, our x is either equal to minus 3 over 4 or x equals to minus 2. So this is the root of the equation. This is quadratic equation using completing the square method. And if you compare this one with the one we solve in factorization method, we check that the answer is the same. So after quadratic completing the square method, the last method to use is using quadratic formula, which is I can call it the simplest one. So using quadratic formula, there is a quadratic formula which is derived from the completing the square method. Quadratic formula is given as x is equal to minus b plus or minus root of b squared minus 4ac all divided by 2a. So this is the quadratic formula, and as I said, this quadratic formula is derived from the completing the square method. That is, when you are given ax squared plus bx squared plus c is equal to 0, if you solve this following the steps of solving using completing the square, you are going to arrive at this junction. So let's just take one example and see. Example, let's solve our previous example, which is 2x squared plus 7x plus 6 is equal to 0. So before you solve here, you need to collect your data. As I said, the coefficient of x squared is always a. Our a is 2, b is the coefficient of x, which is 7, and c is the constant value, which is 6. Just come to your formula. Where you see b, you write 7. If you see c, you write 6. And if you see a, you write 2. So x is equal to minus b, that's minus 7, plus or minus root of b squared, 7 squared minus 4 times a times c, all divided by 2 times a. Our a is 2. So this is equal to minus 7 plus or minus root of 7 squared, 49, minus this, 4 times this, 8 times this, 48, which is equal to 4. All divided by 4. And this is equal to minus 7 plus or minus root of 1 divided by 4. Now what is root of 1? Root of 1 is 1. So our x is equal to minus 7 plus or minus 1 over 4. Also, when you come to this junction, you just take the positive 1 or the negative 1. So x is either minus 7 plus 1 over 4 or minus 7 minus 1 over 4. Like this, minus 7 plus 1, minus 6 over 4, or minus 8 over 4. So at last, our x is equal to minus 3 over 4 or minus 2. So you see, now we use all the three methods to solve a quadratic equation. Okay. Now we are going to see the nature of quadratic roots. nature of quadratic roots or roots. And this, the nature will tells us how when given a quadratic equation on how the nature is going to give, either the roots are equal roots, or the roots are real numbers, or the roots are complex numbers. There are some cases. The first case here is case 1. It says if b squared minus 4ac greater than 0, then the roots are real and equal. Case 2, if b squared minus 4ac is equal to 0, then the roots are real and equal. Sorry, this one is the roots are real and unequal, while this one is real and equal. The last case is case 3, which says that if b squared minus 4ac is less than 0, then the roots are complex. These cases are very, very important. Let's take one example. If, for instance, we are asked to find the nature, what is the nature of the roots of the equation, this one, let's say 2x squared minus 3x plus, let's say 6 is equal to 0. Assuming we are to find the nature of the roots of this quadratic equation. So we are not going to stress ourselves to solve the equation to see whether the roots are equal or unequal or whatever. Just check by using this discriminant. That is, the first thing you should find your a from the equation. My a is 2, b is minus 3, and c is 6. Just check b squared minus 4ac to see whether it is less than 0 or equal to 0 or greater than 0. Now our b is minus 3 squared minus 4 times 2 times c is 6. We're going to have 9 minus, this is 12 times 4, that is 40, is it 48? 48? 12 times 4, 48. So 9 minus 48, we are going to have minus 39. So at n, our discriminant b squared minus 4ac is less than 0 because the answer is negative. So then the roots are complex. The roots are complex. This is how to check the nature of quadratic roots. If, for instance, after solving the answer is maybe positive value, then we can say that the roots are positive. The positive is it 0 or equal to whatever, then we say the answer is whatever from the cases. For instance, I may be given maybe, let's say x squared minus 5x plus 6 is equal to 0. Checking here, our b is what? 5. We have minus 5 square minus 4 times a is 1, c is 6. This is 5 here is 25 minus this times this is 24. 25 minus 24 is 1. So you see, in this case we are having positive answer. This implies the roots are real and unequal. The reason why the roots are unequal is because it is not 0 but what? Greater than 0. And when it is greater than 0, it is real and unequal. So this is discriminant. So the next, we are going to see symmetrical functions of quadratic roots. Symmetric function of quadratic roots. In symmetric functions, we are going to discuss on sum of quadratic roots and the product of quadratic roots. Now let's alpha and beta be roots of the general quadratic equation ax squared plus bx plus c is equal to 0. If alpha and beta are roots of this general quadratic equation, then we know that x is either equal to alpha or x is equal to beta. Or before this, yes, it's the same. X equals to alpha or x equals to beta. Having known this, we know that if we can turn it down, we may have this is equal to 0 or this is equal to 0. Having this, we know it's the same thing as since it is 0, they are all having 0, you can just multiply them and equate all of them to 0. We expand. This times this, we have x squared, x times alpha, beta, minus beta x. This times this, minus alpha x. This times this, we have plus minus times minus plus alpha beta is equals to 0. So having this, just factor out minus here. We're going to have x squared minus into beta or beta x plus alpha x plus x is equal to 0. Also, at last I can factor out x. X squared is equals minus alpha plus beta. All x is equals to alpha not equal to this b plus alpha beta is equal to 0. So what the essence of doing this is to find the formula of finding the sum and product of the roots. Now let me name this equation 1 and let me name this equation 2. Having named this here, I want to compare this one with this one. And to compare, we have to divide through here by x, by the coefficient of x squared, which is a, so that we are going to have a unique x squared here. So dividing the coefficient here, we are going to have x squared plus b over ax plus c is equal to 0. I can call this equation, let me call it star. Now, I want us to compare equation 2 and equation star. Compare 2 and star. By comparing, look at it. From, if I take the coefficient of x here is minus alpha plus beta, x, without the x, only the coefficient, is equal to b over a. If I take minus 2, I'm going to have alpha plus beta, which is equal to minus b over a. This is very, very important. Look at it, from the beginning, we said alpha and beta are root of this. So the sum of the roots, that is alpha plus beta, it means sum of the roots. And the sum of any quadratic equation root is given as minus b over a. Now let's see, comparing, let's take the constant value, which is alpha beta, is equals to, we compare it with, sorry, here over a, dividing through by a, we're going to have over a here. We're going to have c over a. Look at it. Alpha beta means alpha times beta, which is product. So the product of any quadratic roots is given as c over a, while the sum is given as minus v over a. And note this formula, this one, equation 2, can also be used for finding quadratic equation whose root is given, whose roots are given, whose roots are given. So this formula, x squared minus alpha plus beta, x plus alpha beta is equals to 0, is a formula used in finding the quadratic equation whose roots are given. We are going to see example of this. Now, don't forget, this is very important. Minus b over a is the sum and c over a is the product of the roots.